Hi everyone, welcome to my channel. In this video, we will build complete serverless to-do application using AWS CDK. We will integrate AWS AppSync, Lambda, and DynamoDB to create a scalable and modern application. In this project, we use GraphQL API to manage to-dos where we can add, delete, and update and fetch to-do dynamically. In the end of the video, you will have your own AWS serverless app running on AWS. Before starting the video, please make sure that there are few prerequisites and setups. Please make sure that you have installed in your system Node.js. In my case, I am using JavaScript, that's why I use Node.js. If your programming language is different, like Python, Java, and C Sharp, you can install the related one package manager. Then you have installed in your system AWS CLI to interact with AWS account, and also you have installed globally AWS CDK Cloud Development Kit in your system. And the last one is you have your own AWS account. Our project structure has three main parts. First one is graphical schema, second one is Lambda function, and third one is CDK stacks. In graphical schema, we structure our API, and in Lambda function, we define our business logic of to-do app. Lastly, in CDK stack, we can write our infrastructure as a code that deploy AppSync, Lambda, and DynamoDB. Now let's start our project. Now we need to create a folder for our project. So I make a folder. I call my folder name is AppSync, Lambda, AppSync, Lambda, DynamoDB, and open this folder in command prompt. Now I am going to install a boilerplate code that provides CDK. CDK is a cloud development kit. So we need to install our boilerplate code. For this purpose, we run our command CDK init app dash language to TypeScript. So I prefer to write our infrastructure in TypeScript. So if you want to write your infrastructure in Python, Java, and any language, then you can write your preferable language. I will write my infrastructure in TypeScript. That's why I use TypeScript template. It will take few time to install our template in our project folder. As you can see, there are a few files and folder. This command has been generated. Let's wait a few minutes to complete the whole process. As you can see, our template installation has been complete. Now open this template in VS Code. Now first we need to create our GraphQL API schema for our to-do app. For this purpose, we need to create a folder for our GraphQL schema. I will create a folder name is GraphQL, and in the folder, I will create a file called schema.gql. In the file, we will write our GraphQL API schema. In GraphQL, there are two operations mostly used in GraphQL. First one is query, and second one is mutation. Query is used for getting the data from database, and mutation is used for updating, deleting, and adding the data in the database. So let's write our API schema. First, we need to write our query operation. For this purpose, type query, and query have one field called get to dos. Now what this get to dos will return? It will return list of to dos. What is list of to dos? We will create to dos subject. To dos have type to do, and in to do there are few properties called id is equal to id, and it's required, and title, string, and is also required, and it's completed or not. And what is the status of to dos? We will define as a boolean. What this API do? The query operation have get to do fields, and this get to do fields will return list of to dos. What is list of to dos? List of to dos is a properties of id, title, and completing status. Now we will write our mutation. Mutation is used for adding, deleting, and updating the data into database. So we can write our mutation keyword mutation. In mutation, first we have a field called add to do, and add to do will take parameter called to do. What kind of to do data? To do data has to do input, and it will return also to do. Now we will find what kind of parameter this add to do will take. We can define it. So type to do input, and to do input have the same kind of properties called ID, title, and completion status. Okay, there is some mistake. Instead of type, we can write it input, because we are adding parameter to do input into add to do field. So that's why we can use input as a parameter. So here is our add to do field. Now we can create our update to do field, update to do, and update to do will take the same parameter, and it's also return to do. It's also return single to do. And the last one is delete to do field. Delete to do field will take one record ID. So that's why our parameter will be to do ID. And to do ID, what kind of to do ID? To do ID is a string type, and it will also return a string status of our to dos. If deleted, then true. If not deleted, then return false. So let's save this. So here is our complete graphical schema for our to do application. Now let's create our business logic in our Lambda function for this schema. For this purpose, we can make a folder for our Lambda function called Lambda. You can name as you want. Lambda in Lambda. Now open this Lambda folder into a command prompt to install our package manager. Now run npm init. Npm init command is used to create a package manager into a single folder. As you can see, it will create a package manager file that now we need to install one library that we need to in our Lambda function, that is npm I AWS SDK. AWS SDK software development kit is used to interact with our Lambda function with AWS resources. That's why we need to install this package into our Lambda folder. Okay, our folder in Lambda function have a package manager, package.json file. In package.json file, we have a AWS SDK. Now first we need to write our add to do business logic. For this purpose, we need to create a file called add to do. In add to do, now we need to import our AWS SDK package, all as AWS from AWS SDK. Okay, now we need to create our add to do function, async function add to do, and also export this add to do, export default add to do. Why we do this export default? Because we can import into another file. That's why we do export default add to do. We can write our business logic in our try catch statement. Console.log DynamoDB error. So how can we add our data into a database that called DynamoDB? So first we need to make a client of our DynamoDB database. For this purpose, we need to create a new aws.dynamodb.document client. This document client is used to write our code item into our database. Now we need to take this into our variable name with docs client. Okay, here is our document client for our DynamoDB. What kind of data we need to add into our database? Data will be to do report. To do, what kind of to do data type, and it will do to do. we can define our to do data type. To do data type to do and to do. Okay, and to do have ID. ID will be string. Title is also string, and the last one is complete status, completed, and it's a boolean. Add to do function will take a parameter called to do, and to do, what kind of to do data has an object, and object has a few properties called ID, title, and completion status. Now, how can we add into our database? For this purpose, we need to await for a async await, or copy this our client. In client, there is a few functions. As you can see, is that delete function, get operation, put function, query function, and scan function. For adding data into a database, we can use put function. Input function will take one parameter called params. We can define it params, and also can add promise because it's a async await function. So that's why we use promise. What kind of params this input function will take? In we can define it const params. The params parameter will have a table name of our database and what kind of report we need to add into a database. So first we define the table name of our database. Table name process.env to do's. Please make sure that your to do table will be same as you make the DynamoDB table into AWS infrastructure. And second properties of params will take is what kind of item we can add into our database. So it's a to do items. So we can items will be to do. That's one. Okay. And it also return to do's. And this one will return null. Let me explain the whole code again. First, we need to add AWS SDK library into our add to do file. Then we need to create our document client to interact our database DynamoDB. Then we make our function, and in function document client have a function called put, and in put function it will take one parameter, and this parameter is called params. And params will take two properties. One is what is the table of your database. In my case, my DynamoDB table will be to-dos table. If your DynamoDB table name will be different, then you can edit this one. And also what kind of data we need to add to our database. So in my case, the data will be input, title, and completion status of our database. So we can pass it into items. After that, whenever this function is run, our data will be added into our database. Now we need to create our second business logic. Now we need to create our delete to do business logic. For this purpose, I will go Lambda function folder and create a file delete to do.ts. In this file, we first need to import AWS SDK. Just copy paste these two lines and paste in delete to file. I will import AWS SDK and I will make a client of DynamoDB, which is document client of DynamoDB. Now I will make a function of delete to do async function delete to do and export this function export default delete to do. Let's try catch. We can remove try catch and console.log DynamoDB error. Okay, error. In delete to do function, this function will take one parameter, which is a record ID, single record ID. What will be a single record ID? We can pass it to do ID, and you can also see this parameter in our GraphQL API. We can pass our to do ID. To do ID will be a string type, so we can find it TODO ID. TODO ID will be string. Let's create a function await because it is a async function, and that's why we need to add this keyword is await. Copy this variable client variable dot. Now we need to delete function, so that's why we can select this delete function, delete, and delete version will take one parameter which is a params, and params have two properties. One is table name, another is record ID. So let's define params dot promise because it is a async await. Now let's define params const params. Params has two properties. One property is table name of your DynamoDB table name process dot env dot todos table, and the second property is a key, and key will take a props of ID. ID is equal to our todo ID, and todo ID is our code ID, which is a single ID. Now return todo ID, and also return null. Return null. So this is our delete todo business logic. This function will take one parameter which is todo ID, and it will delete the record. That ID will be matched based on our parameters and DynamoDB record. Now let's create our next business logic, which is get to those, where we can get all our records in a single click. So let's define get to those .ts file. In get to those file, we can again need these two lines. Just copy paste these lines into get to those. First one is AWS CDK software development kit to interact our Lambda function to AWS resources, and second one is document client to read and write data into the DynamoDB database. Now create a function async function get to those, export this function, export default, get to those, try catch statement, and console.log for error log, for checking the error log, DynamoDB error, and it will return now. Now let's get our logic await. Copy this document client. Now we need to get our data into a database. If we want to get a single record, then we can use get function. If you want to query a specific record, then you can this function. I want to use a scan function because I want to get all record into our database. That's why I will use scan function. And scan function will take params parameter or promise. Now let's create our params const params. It will only take a table name of our database. Now let's copy paste from here and paste it into get to those file here. What will this function will do? This function will go to this DynamoDB table and scan the whole record and get all the data into our database. Now we need to return data. For this purpose, we can paste it into a variable. We can get into a variable and return this data dot items. And the last business logic is update to do. Now we can create update to do file, update to do .ts. I will create the whole code, then I will explain it shortly. Here I write my whole update to do code. What this code do? First, it will import AWS SDK and document client for getting the data into database. Then what this function do? This function take a parameter to do, and this object has a code ID. And if our record ID will be matched, then we can update our specific record. And if we cannot update the record, then it will take as it is, and it will update the data into our database. Now let's import all this business logic, which one is add to do, delete to do, add to do, and update to do files into a one single file to handle in a single end. For this purpose, we need to create a main.ts file and import all our business logic into it. Import add to do, from add to do, import, delete to do, from delete to do, import, get to do's, from get to do's, and the last one is update to do, import, update to do's from update to do. Now let's create our function. Our function name will be handler export dot handler. Here is our function, and this function is a async await, so that's why we can use async. And this function will take one parameter, which is event. This event will receive from the GraphQL AppSync, so that's why we need to define our data type of GraphQL AppSync. For this purpose, AppSync event. What will be the AppSync instrument? Now I will define this event type. AppSync event. When our user add a data into a database, what will our API do? It will match the field name, which is add to do, and the parameters of our data, which is the properties of ID, title, and completion status. This AppSync event will pass to the Lambda function. So that's why we use this event AppSync type into an event parameter. Now let's define our data type. Info colon field name. Our field name will be string. In our case, our field name will be add to do, update to do, delete to do, and in query we have a get to do field name. And second, we will take arguments. If we want to add a data into a database, then we will take to do arguments, and if we want to delete a data into a database, then we will take a single to do ID. Which one is to do ID? Now we need to define it into our main.ts. So if we want to delete a single to do ID, to do ID will be string, and our to do have to do type. Also we need to define this to do type. To do have ID. ID will be string. Title also will be string, and last one is completed status, which is boolean. So this is our event parameter. This event parameter has a data type AppSync event, and AppSync event has this data type. Now let's get our switch statement. Switch event dot if event dot info dot field name. Now let's define our cases. Case 1 will be if our field name will be add to do, copy paste add to do, field name will be add to do, then return await keyword used because it is as async await, that's why we use async. Then return this business logic, which is add to do, and this add to do will take one parameter, which is the object of to do. Now we need to pass this our add to do function, which is event dot arguments dot to do. Our second case will be delete to do. Now copy paste and return await delete to do function, and delete to do function will take one parameter of record ID. So we will pass this event dot argument dot, this one is to do ID, to do ID. Case 3 will be copy paste get to do's. If our case will be get to do's, then show the all the record into our database. Get to do's function, and that to do function will not take any parameter. We can see it in our Lambda function, get to do's function, and this get to do function does not take any parameter. It will scan the whole database and give back the all data into our screen. And the last one is case update to do. If our field name will be update to do, and it will return update to do function, and this function also take to do event dot argument dot TODO. And last one is default case will be null. Default return null. So this is our complete business logic of our Lambda function. What this function do? This is a main.ts file. It will inherit all the TODO's business logic that includes add TODO, delete TODO, and get TODO and update TODO functions. If our field name will match add TODO, that is schema which is add TODO, then it will call the function of add TODO. If our field name will be delete TODO, then it will call the business logic of delete TODO function. And the same way, if we call the TODO get TODOs, then it will return all the data into a database. And if we want to update data into a database, then we can use this function as well. Now our business logic has been completed. Now we will go into lib folder and start writing our infrastructure from here. Now let's just start writing our infrastructure code. First, we need to decide what kind of resource we can write. First one is AppSync API. The second resource we can write is Lambda function. And third one is our DynamoDB table. Now let's import our necessary library. First library will be AppSync library. Import all as AppSync from AWS CDK lib dash AWS AppSync. The second library we need to import is Lambda function. Import all as Lambda from AWS CDK lib backslash AWS Lambda. And the last one is DynamoDB. Import all as DynamoDB from AWS lib first AWS DynamoDB. Now we need to create our AppSync constructs. New AppSync dot GraphQL. In this GraphQL, there is a few properties. One is the scope of this construct. Second is the ID of this construct, and third one is the properties of this construct. So we are creating this construct in this tag. So this scope is this, and ID name will be API. You can change as you want. And properties of this construct is, and the properties of the first, the name of this API is CDK AppSync TODO's API. And second property is schema. In schema, we can define the path of our GraphQL schema. Our schema lies in GraphQL folder. And in GraphQL folder, there is a file called schema.gql, and here our schema lies. Now we can define the path of our schema. AppSync.schema file.from message. From message, we have a GraphQL folder, and in GraphQL folder, schema.gql file. And the third parameter is, okay, what is the issue? And the third parameters we need to find is authorization of our AppSync API. So we can use default authorization that AppSync provides. So let's configure it. Authorization config, default authorization type. In default authorization type will be AppSync dot authorization type dot API key. I will use API key. If you want to authorize your API with IAM-policy, then you can use your policy authorization. And if you want your Lambda functions, OIDC and user pool, then you can configure your AppSync authorization with that. I will use API key configuration. Now we need to define the duration limit of our API. For this purpose, API key config and expire. Our API will be expired within 1 year. So we can find is that CDK dot expiration dot after CDK dot duration dot days. I will use 1 year duration. I will enter 365 days. After 365 days, this API authorization will be expired, and you need to configure your new authorization duration for getting the API from AppSync. Now we can get this AppSync API with variable for this const API. Now let's define our Lambda function. New Lambda. Copy this Lambda from here. New Lambda dot function. In Lambda function also have few properties. First one is scope of this construct. Second one is the ID of this Lambda function. And third one is the properties of this Lambda function. The first parameter is scope. Our scope is this. The second parameter is the ID of this Lambda function. I will call my Lambda function is AppSync Lambda function. And properties of Lambda function. First, we need to define the runtime of our code. For this purpose, we need to define runtime. Runtime of our code is lambda dot runtime. We are writing the code in TypeScript, so that's why we can use Node.js. But if you want to write your code in Python, Java, and C#, then you can select your right environment as well. Second parameter is handler. In handler, we can define the file and function of our Lambda function. So our main Lambda function lies in Lambda folder. And in Lambda folder, we have a main.ts file. This is our main file that inherit all our Lambda functions. And in main.ts file, we have a function called handler name. So our function name is handler and our file name is main. So we can define main.handler. Main is a file name and handler is a function name. And where is our code lies? We can also define the folder of our code. Code lies in lambda.code from assets, and from assets we have a lambda folder. And last one is memory size of our function. Our function memory size will be 1024. And also we can get this lambda into a variable const TODO lambda. So here we define our lambda construct. So this is our lambda function. Now we need to make our lambda data source. So this lambda will work as a data source for our AppSync API. For this purpose, we can get our API.lambda data source. And what is the name of this lambda data source? We can call it lambda data source. And what is your lambda? Our lambda will be this. So here we define our lambda as a data source. Now get this lambda data source to a variable const lambda ds. Now we need to configure our resolver for our data source. Now we need to create a resolver from our data source. What is the function of the resolver? Resolver is used in AppSync API. It is used for getting the data from lambda function and adding the data through the lambda function. For this purpose, we can define lambda as a data source dot create resolver, and we can define the name of our resolver. Our first resolver will be a query the get to dos. For this purpose, we need to create query resolver. You can name as you want, and you can change this name as well. Create resolver query get to dos. And properties of this resolver is, first we need to define the type name. The first resolver of our lambda data source is query. So we can go to the schema.jql. We can find that our first resolver will be the query name. So copy paste this query and past is this type name. And second property is field name. What is the field name of this query? In query, we have only one field. So let's copy this get to dos. So here we make our one resolver. We can define the same resolver for our mutation. Let's create mutation. I will copy paste this and create resolver mutation. Add to do. So our type name will be, so in add to dos, our time will be mutation. Copy this and paste it in on the behalf of query, and field name of our mutation, first mutation is add to do. Okay, add to do. Now create the same from delete to do and update to do. Lambda create resolver mutation from delete to do, and mutation will be same, and field name will be delete to do, and also for update to do. Update to do, and just change this update to do. So here we define our resolver, and lastly we need to create our database, DynamoDB database, and pass the full access of read and write policy from the lambda function. For this process, first we need to create our database, new DynamoDB.table. Scope of this table is this, and name of this construct is CDK TODO table, and properties of this table is first is name of this table is table name. Table name will be TODO table, and partition key will be name. Name will be ID. Okay, we can pass it in column. ID, and type of this partition is DynamoDB dot attribute type dot string. So here we define our DynamoDB table. Gonna get this into a variable const TODO's table, and we need to pass this table to grant access to the Lambda function. For this purpose, TODO's table dot grant full access for Lambda function. Our Lambda function will be this one. Copy paste this. Also, we need to define the table name of this DynamoDB into our Lambda environment variables, because in our Lambda function we pass this, our table name will be TODO's table. So make sure that our table name will be same. For this purpose, we can write it TODO's Lambda dot add environment. In add environment, we can pass the same name of our table name. Copy this and paste here in brackets TODO's table, and alias is TODO table dot table name. So here we define our complete infrastructure code. Let me revise this code again. First, we import some libraries that include AppSync, Lambda, and DynamoDB. And here we create our AppSync constructs. In AppSync construct, we pass our API name and the file of our schema, and also add authorization configuration of our API. In our case, our API will be expired within 365 days. And then we can write our Lambda function. Our Lambda function lies in Node.js, so that's why we can select runtime of Node.js. And our Lambda function main file lies in main, and in main there is a function name will be handler. So that's why we can call our handler name is main.handler, and our code lies in Lambda folder. Then we can create our Lambda as a data source. So we can make our Lambda as a data source. After then we create a resolver from our Lambda data source. This resolver will read and write operation from Lambda because of Lambda as a data source. Then we create our DynamoDB table and grant full access to read and write operation of our Lambda function to DynamoDB table. And lastly, how our Lambda function will know the table name of our DynamoDB. So we can pass our environment variable, and our table name will be same that we can use in our Lambda function. Now let's deploy this whole TODO app into our AWS account. Now let's just deploy this project. For this purpose, we can open command prompt. Before deploying infrastructure on CloudFront, we need to compile this TypeScript code. For this purpose, run this command npm run build. Npm run build compile the TypeScript code into a JavaScript code. After this compilation, we can deploy our infrastructure on AWS. Let's wait to finish this compilation. Okay, our compilation has been complete. Now we need to run CDK deploy command to deploy our infrastructure code on AWS cloud. This process will take few time to complete the whole process. So let's wait few minutes. Please enter yes to start deploying the infrastructure. You can also verify the infrastructure deployment process on AWS cloud. Let's open AWS cloud, and I will already log in my AWS account and go to CloudFormation. You can see that our stack process in progress. So let's click on it and resources, and you can see that our 2 process has been complete and 2 is in running behind. So let's wait to complete the whole process. Okay, our infrastructure stack has been deployed. Now refresh this. You can see. Okay, let's refresh this. You can see our stack deployment has been completed. Now open your AWS sources. First one is AppSync. Open in new tab. Second one is Lambda function. And third one is DynamoDB. In AppSync API, you can see there is a one API, and in API in query section, you can see that our two operation has been lies in there. One is query and another is mutation. Now, if we add data into DynamoDB, we can click on mutation, and in mutation we can add our data. Okay, we can add a demo data. First one is true, complete status is true, ID is equal to 1, and title will be shoes. Now enter this data into DynamoDB database using the help of AppSync. Now run this. Now run this mutation. Here you can see we can get response from our database, and we can also verify this data into database. Let's go to our DynamoDB database and go to table section. Let me go and explore the table items. Here you can see our data has been added. Now again add second data. Our completion status will be true, ID will be 2, and title will be shirts. Now run this our database, and you can see that our second data also has been added. So now we need to test our queries of our database. Now let's click on this query section and add this. In query, it scan the database and get back the whole code in our database. So now run this command. As you can see, it responds all our code in our database, and you can verify our code into our database as well. And you can also check your Lambda function. Lambda function is your business logic. Go to the functions, and you can see your code in code section. Here is our complete business logic. You can check the code as well. Now we can check how to delete data using AppSync. Now add again mutation and delete one item. I will delete ID1 item. Add ID1 and delete this item. Now verify item has been deleted on our database or not. Go to database and check. As you can see that our ID1 data has been deleted. Whenever I run this API, it calls the resolver. Where is our resolver? I will show you in schema section. In schema, you can see that here is our resolver that we created in our code. These are our resolver. Then it will trigger the Lambda as a data source. In our case, as a Lambda as a data source, work to handle to retrieve data from the database and add data from the database. And this Lambda logic has responsibility to add and delete data into database. So here is our complete code. You can also tell your updated API as well. Simply you can update your singular code into database. So in this video, you learn how to make a serverless to-do app using AppSync, Lambda, and DynamoDB database, and how to integrate these services into each other. If you like this video, then hit like and subscribe.